IT Elective 3. Intro to Microcontroller, Arduino. Course description. This course aims to explain the Arduino microcontroller through hands-on work creating simple machines with embodied behaviors. The Arduino is a versatile resource for physical projects for students in all disciplines. This course brings students over the beginner's threshold to a basic understanding of the use, terminology, and potential of the Arduino. The first portion will teach the essential skills for creating a simple sensor-driven physical computing system, and the second portion will reinforce those skills by making a simple interactive project. Topic outline. What can I do when using Arduino? Why should I choose Arduino? Terminologies to help out. Brief history of Arduino. Arduino and its key features. What is Arduino? Arduino is also an open-sourced platform, which means that anyone is able to use it, for free, as well as make adjustments to the code to fit their needs. It consists of a circuit board, which can be programmed, referred to as a microcontroller, and a ready-made software called Arduino IDE, Integrated Development Environment, which is used to write and upload the computer code to the physical board. Arduino is a prototype platform, open source, based on an easy-to-use hardware and software. Brief history of Arduino. Originally started as a research project by Massimo Bonzi, David Quartiles, Tom Ego, Gianluca Martino, and David Mellis at the Interaction Design Institute of Iberia in the early 2000s. It builds upon the Processing Project, a language for learning how to code within the context of the visual arts developed by Casey Rees and Ben Fry, as well as a thesis project by Hernando Barragan about the wiring board. The first Arduino board was introduced in 2005 to help design students who had no previous experience in electronics or microcontroller programming to create working prototypes connecting the physical world to the digital world. Brief history of Arduino. Arduino is the first widespread open-source hardware project and was set up to build a community that could help spread the use of the tool and benefit from contributions from hundreds of people who help debug the code, write examples, create tutorials. The openness and ease of use of the project has led to mass adoption of microcontroller-based electronics projects and was a catalyst in the creation of the maker movement. Arduino has become the #1 choice for electronics makers, especially for developing solutions for the IoT marketplace. Key features of Arduino. Arduino boards are able to read analog or digital input signals from different sensors and turn it into an output, such as activating a motor, turning LED on/off, connect to the cloud, and many other actions. You can control your board functions by sending a set of instructions to the microcontroller on the board via Arduino IDE, referred to as uploading software. Arduino IDE uses a simplified version of C++, making it easier to learn to program. Arduino provides a standard form factor that breaks the functions of the microcontroller into a more accessible package. Arduino does not need an extra piece of hardware, called a programmer, in order to load a new code onto the board. You can simply use a USB cable. What can I do when using Arduino? You can create awesome and cool Arduino projects. A cheap electronic board that lets you build not only complex but also one-of-a-kind electronic systems. You can use just the board or attach it to some electronic project to make it do some amazing things. You are able to work with the board making sounds, blinking lights, sending out signals to control what is on the screen ahead of it, and so many other things. Why should I choose Arduino? Works across many platforms. The IDE that works with Arduino has the ability to work with pretty much any operating system that you want. It will work with Mac OS, Windows, and Linux. Open source and free to use. Programmers are able to come and use the platform and the software, as well as make changes to them whenever needed. Simple environment. The Arduino environment is similar to the C++ environment, but has been made even simpler to use. A large community. You will be able to find many forums and other locations where you can ask questions, look at tutorials, and find answers you need when working on your project. Terminology to help out. Breadboard. This is a tool that is reusable for building circuits. It makes it easier to connect the circuits without having to get them permanently attached to the board. It is also a stable surface that will connect all your components together. Compiler. The compiler is a piece of software that will take your written program and translate it into something that the Arduino microcontroller is able to understand. Device driver. This is a piece of software that makes it so that the computer is able to communicate with the devices that are attached to it, such as the Arduino board. Start. Terminology to help out. EEPROM. This will stand for Electrically Erasable Programmable Read-Only Memory. This is a computer chip that will be written and rewritten with the code that you want. External interrupt. The external interrupt means that something that is outside of the processor or the computer system and it needs your attention. Flash memory. This is one of your memory choices. It is going to retain the data whether there is power to the system or not. A good example would be the flash drive, which is going to store files, even if it isn't plugged into your computer. Terminology to help out. Digital input/output. Digital pins are known to have either a high or a low value. You are able to pick from a wide variety of digital pins based on the type of board that you get. Analog input/output. This is opposite of working with digital. The analog is going to receive a continuous electrical signal, while the digital option will focus just on whether the value is either 0 or 1. Processor. This is the part of the system that is going to take the instructions from the computer. Terminology to help out. Serial communication. When this kind of communication is occurring, it means that the two systems are sending digital pulses between them at a rate that you determine. Sketch. This is what the Arduino code is known as. It is going to consist of the instructions that you will send to tell Arduino how to run. You will need to compile the sketch and then upload it to your board. SPI, this stands for Serial Peripheral Interface. It is in charge of keeping the data communication protocol over small distances. Thank you.